if we think about the term phosphorylation, that kind of sounds like doing something with phosphate. You know, Asians like to do, right? I think. Communication, okay, whatever. What about substrate? What does that mean? Very good. That's the biological term for a reactant. So to me, substrate level means you're taking your reactant and you're phosphorylating it. You're adding phosphate to it directly. Directly. So this would make reference to taking ADP, adding an inorganic phosphate to it, and making from that, or making ATP from that. Yeah. Cool. So this would be substrate level phosphorylation. Now, if you invested I invested $2, because that's all I have, and I got $4 now. And what was my net? Two plus two. So I think we should write down that you have a net of 2 ATP produced. And this is more appropriate than my statement before. Now really, it's in truth, you've only produced 2 ATP because you've backed out the 2 investment. You've produced 2 of your 38. So that would equate to basically, okay, nothing. You produced very little. So now you understand why when you close your mouth and then hold your nose, like why you stop. Why do you stop? I mean, like, why do you drown? Why does an individual die?
Because those 2 ATPs is not enough.
That 2 ATP is nothing, right? So, we said earlier, like, if you stop the O2, you stop. That's actually a little bit false. You stop the O2, you stop the reaction, so you stop the mass ATP production that would occur inside the mitochondria, so, therefore, you stop. Right? Now, some things are anaerobic. I mentioned that earlier. There are some creatures that are O2 hating. O2 haters, as I like to call them. You gotta shake off the haters first off. Anyone get that? Y'all never heard that before. Wow. Okay. Anyway, some bacteria are anaerobic exclusively. Now that would make sense. What's the difference between me and a bacteria? A lot. For probably the most basic principle is that I'm a lot larger than a bacteria. Well, with size comes complexity, and with size and complexity comes a need for energy. Right? The bigger an object, the more energy that it takes to manipulate the object. Okay, so I would need tons of energy. Bacteria are very small, little energy requirement, so they're okay with their 2 ATP. However, I need more than that. I'm larger than a bacteria. So my ATP requirement is much larger. So tomorrow we have to describe exactly how could we become aerobic? How could this proceed? Now, that's not all we've produced here. We've produced a little something else as well. Because we've taken off some of our hydrogens, which means that we have produced a couple of the NADHs. Remember that basically making NADHs is like putting money in a bank account. It doesn't buy you anything, but it has the potential to buy you something later on.
Does it grow in value?
Do what?
Like, would it grow in value?
As you make more NADH, then you have more potential. So as I make more dollars, as I like to call it, as I make more dollars, I can buy more stuff, bigger stuff. And we're going to use this in the ETC later on. You want to do more stuff, you need more money.
So bacteria always.
Which, well, and see, then you're like, well, I save money like long term to go spend it in a very short term, correct? So you're it's really a much quicker reaction than that. So like if you're working out, you are not spending all of your NADHs. You're just doing this process more to make more NADHs. So like when you're exercising, this thing is just shot up in value in its speed. So it's not like you're doing this all the time, creating bankroll basically, and then blowing the money from your bank. That's not it. You're only doing this when it's needed. So as you're watching, I don't know, whatever show it is these days, on your couch, then this is going very slowly. But you go to the gym, this is occurring very quickly. So NADH is saving up like a bank is a little bit of a misconception because saving up, it implies like saving up over time. What I'm saying is that NADHs basically represent potential energy. You can cash in very shortly after making them to produce lots of ATP. So a better analogy would be like you only work when you need to go buy something. So in summary for glycolysis, I think this is a good summary. So please draw it with me. You start with 6 carbons and some oxygens and hydrogens that are associated with the 6 carbons. And the name of that molecule is called glucose. You'll notice I've drawn 6 little balls there, and that 6 is representing each carbon. I'm not drawing all the O's and H's in there because I'm lazy. You'll just pretend that they're there. And all we have done is we have invested 2 ATP. It's a reactant, and that's actually a 2, and I apologize for that looking not like a 2. But that's an investment on the reactant side. And in glycolysis, all we are doing is literally taking a pair of scissors, breaking this into 2 pieces, so that we are left with these 2 molecules, which is no longer glucose. Of course, it is 2 molecules of pyruvate. Gaining of electrons. You are gaining 2 electrons on NAD+. Now, for biology's sake, because a lot of times the 2 electrons aren't written there, I just tell people, you know what? Just remember that if you gain H, you're doing reduction in biology, and you'll be okay. That's not. Now, chemists would hate that, but biologists are simple enough. It's simple enough, and it works. Yay? Yeah. So tomorrow we just really have to talk about how can we continue to take our 2 little sugars, the 2 little sticky tabs here, and how can we break them down even more so that they can become little CO2 molecules and blow away. And just blew them away. Go away, CO2 molecules. And what about my H's along the way? How can I continue to bank my H's? And then how do I spin them? Right? So this is much like a job. What do you do? What do you do with the money? What do you spend the money on? So we just need to talk about how do we continue to break down to form CO2. How am I collecting